All right, that's Willie. So we're ORCA. We're designing a semi-autonomous field explorer and safe for our 420 capsule project. Today is April 3rd, 2019. This is our second demo. So to overview what we're going to present today, we're going to go over our significant progress with the rover since our last demonstration from different perspectives. Hardware first, then mechanical, then software. We're going to talk about any errors that we've had and kind of wrap the presentation up, see if there are any questions, any concerns, or advice.
So on the hardware side for our significant progress, last time we demoed, we did everything on the board, but now the PCB is here, we've got everything soldered on, all the components, all the power is running through the PCB, and all the components now. We've tested everything, all of the sensors, the IMU, the driver board all operate as they should. The only thing we're missing testing right now is the GPS, but we're still waiting for that module to get in.
Okay.
Let's see the top side has both of our DC-DC converters. The one is 7.3 volts for all of the motors and the manipulator and the lights. Then we have a 5-volt converter for the PCB board.
Okay.
That's all connected.
What's the thing with the blinky lights?
That's a USB to Ethernet converter. So
Okay.
our data is being converted and going onto the Pi.
Okay.
Showing that script one.
Yes, sir. Oh, sorry. Go ahead.
So for our enclosure from last time we did our demo, we have all of our penetrators on the back potted, so they're all waterproof, and we have two sides for the enclosure, the top being the two DC to DC converters, the breaker, and the Ethernet, and then on the bottom side is the PCB and the ESCs. And then, so for software?
So the main difference in the software from last demo is that now we're communicating between the two Pis. So we have the Pi 3 here, of course the Pi 0. So on the inside it's going through the tether all the way to the inside. Pretty much the same controls before, but now it's automated. So with everything connected, we have the lights, gripper opening, closing. We have the sensors all reading through the tether, which is what these are. So that's updated values. So we have the IMU, temperature, GPS is not connected currently.
Okay, what's our temperature?
The sonar, about 72.5.
And what's our depth?
Depth is
Or
gonna be
pressure?
pressure 1 atmosphere, 1.07.
Okay.
Surface.
All right. Cool.
Okay.
And motors
so-
work as well.
Yeah. Yeah. So the motors all run. Straight up, down, left, right, turn. There we go. A little jingle for you.
We're playing that on the motors?
That's on motor.
Yep. Pretty interesting, huh? He's a hell of a guy, Professor. So some of our errors that we've encountered and that we're currently going through right now, we're waiting for the GPS module to come in, as I mentioned previously, through dealing with the GPS and kind of putting it on the board through travel. It got damaged, and so we were waiting for the new module to come
Where's
in.
the antenna for your GPS?
It's on the PCB, which is...
It's on the GPS.
It's on the GPS module.
Which
We
is
can,
going to be...
we can add an
We
external
could add-
antenna if we need to. But currently, we don't have an external antenna.
So when this thing is on the surface, which is the only time the GPS is going to work, where's the water level compared to where your GPS antenna is?
We'll be able to determine that more after we dunk it in the water tonight and see
Yep.
how buoyant we can make it versus where we want the motor speed.
Because if that GPS antenna is underwater, I doubt very seriously, even
Attenuation.
an inch
You
underwater.
think so? Well, from what
We'll probably
we were
order the
researching,
antenna.
from what we were researching, some of these sensors, including I believe ours, works up to half a foot, and I thought that was kind of strange myself. So we plan on testing that. This
Okay,
afternoon.
well, it'd be interesting. I bet
Yeah.
you lose accuracy at the very least.
Yeah,
But up to half a foot, that's fascinating.
that's what we plan on testing this
Yeah,
afternoon.
because all you're getting is attenuation
Yeah.
of the,
Right.
of the water.
Increased power, maybe that
So-
would help or something. So we're waiting for the GPS to come in, and we're waiting for the potting material for the waterproof sonar sensor. So we've tested all this, like we said on breadboard, and we demonstrated this last time. But we actually researched a way to make this water-resistant sensor, waterproof. So we're waiting for those adhesive to come in, pot this, and then pot the wire connections as well. But we got that working already. And
So have you tried this with potting in there? This ultrasonic sensor, right?
Yes, sir.
Have you tried it with any kind of potting in it?
No, but we watched demos, and people took this exact same sensor
And potted it and made it work.
Yeah,
Okay.
I thought that kind of interesting. It would kind of attenuate some of the frequencies being blasted there, but with a certain type of potting that we got, which is especially made for this, it minimized it. So,
Okay.
Yeah, it's a flexitive.
Yeah. The RTX.
Flexible. Okay.
RTX adhesive. So we're waiting for that to come in. As soon as we do that, we'll pot that and then run straight through. But as you've seen, everything else is working. Right after this, we're going to actually take this to the pool, dunk it. We've already dunked this in water, made sure that it's waterproof. But I guess just as an overview of this presentation and everything, since we met with you last time, we've waterproofed this. We've potted all of the devices. Everything fits inside. It's not in its final state right now. Obviously, it's a little bit of a rat's nest, but we included a divider in there. We have all these different guards now on the thrusters, which is required for the mate. All software has been completely integrated, and the manual portion of this project is done. The only thing is waiting for the autonomous. It should be done roughly tomorrow because we have everything else done. We just kind of put it in a loop, a simple loop. We included these bumpers for travel so nothing gets damaged. We included L brackets here in our design to reduce drag on the motors.
Okay.
For the thrusters. What else? Yeah.
You'll show the new manipulators.
The new manipulators that we've mentioned for mate. It's not a functional requirement, but we got these in. We got in the waterproof motors for these. So we're going to attach them right here, and we will be working. Since it's not a functional requirement, it comes second to the functional requirements.
Right.
And so we'll be working as soon as we get a final demo video concluded on making those work, getting it set up for a fun mate competition. So let me think if there's anything else. Like I said, we're dunking it today, but we've already proved in that amount of water that it is waterproof, water sealed. Obviously that changes with depth. The pool today is roughly 4 feet. So we'll be seeing how that goes. Working the buoyancy of this with those noodles, attaching this. And should have some good news for you in the next few days, hopefully.
All right. Very good.
All right, thank you.